This is part one of the Earth's Resources topic on AQA GCSE Chemistry. This particular chapter, the Earth's Resources, has a lot of quite fragmented parts, so they don't necessarily follow on one to the other. In this first video, we're going to take a look at finite and renewable resources. As always, I'm going to recommend you pause the video and have a go at the activities for yourself before reviewing. So, let's have a think about some key words. What do we mean by what we see on the screen now? So, finite means that we're using something up at a faster rate than it is replaced. It means essentially it's going to run out. Whereas renewable, we will have a constant and consistent supply. So it can be replaced at least the same rate that it's used up. And we're going to look at some examples of those later on within the video. If something is natural, then we talk about a material that exists naturally. It might be something that's grown. Whereas if something is synthetic, we are talking about materials that have been man-made. Okay, so let's move on and develop that a little bit more. On the left-hand side are lots of natural resources, things that are found in nature. Wool found on sheep, obviously, cotton is grown, etc. There are synthetic equivalents out there. Can we identify any of them? Well, wool you might replace with acrylic fibres, which is a polymer, a form of plastic. Cotton you might replace with polyester, which is a polymer, a form of plastic. Silk is nylon, which is a polymer. It's a form of plastic. You're seeing a theme here. Linseed oil, which is used in paints. We can replace that with acrylic resin, which is a polymer. It's a plastic. Rubber can be replaced with a range of different polymers. And finally, wood we might replace with PVC, which is a polymer, a plastic, or we might use a composite, which is MDF, where you actually combine fragments of wood with other things to get to a material that will be useful. So what about these? Are they finite or are they renewable? Well, metal ores that we take from the ground, we are going to run out of. We're not making new metals, so they are definitely finite. But if I shear some wool off a sheep, that sheep will grow wool back and will breed more sheep that we can do the same to. So that's definitely renewable. Crude oil, mined from the ground, we are going to run out and we are actually running out, so that's finite. Limestone rocks quarried from the Earth's crust, again, we're digging them up, they're not being replaced, they're finite. Cotton, however, grows on plants, so that is renewable. Wood growing as trees, we can grow more trees, that's definitely renewable. And coal mined from underground is finite. It doesn't get replaced. It takes millions of years to form, and we're digging it up very, very quickly. So crude oil, which we've spoken about more than once now. Chapter 9 is a dual award topic where we looked at crude oil, and polymers is a triple only topic where some of you will have seen it elsewhere as well. But why is the fact that crude oil is renewable particularly problematic? Or non-renewable, I should say. And first of all, it's because we do rely on it as a fuel. There are many, many alternatives being reviewed, considered, acted on, trialled, and used successfully. But it is still heavily used as a fuel. But it's not only that. Let's go back to this table. Every single one of these synthetic equivalents was a polymer. It was a plastic. And that plastic comes from crude oil. So as we use up crude oil, going to take away the opportunity to make and use all of those materials. Now, these graphs really lay bare the situation that we're in terms of some common resources. Take the time to take a look at one or two of them. Bear in mind, this is the picture in 2036. In A, if we carry on at the same level, and B, if we accelerate at the current level. And we're going to pick out one or two of them. So aluminium, if it carries on at the same rate as the current level, we've got enough aluminium to last 1,787 years. However, it's accelerating. aluminium use is going up incredibly quickly. And so if we were to see it accelerating at the same rate as it is now, we wouldn't have 1,787 years left. We will only have 56. Bear in mind, this is in 2036. That means that aluminium will run out in 2093. That suddenly becomes a little bit more stark. Let's take a look at graphite. Graphite, we've got 40 more years at current levels. So that means we have got enough to take us to 2076. However, if it continues to accelerate in its use, it will be gone by 2034, incredibly soon. And graphite, when you think about graphite being used in pencils is one example, but graphene is one of the big technological advancements in science at the moment, but we're about to run out of the source of it. Let's look at another example. We've got platinum, which is, 336 more years at the moment. Platinum is used a lot. It's actually used in every single car on the road as the catalyst in the catalytic converter. And in reality, although there's still quite a long time there, 83 years. You are looking at 2119. There will be no more platinum. And finally, let's take a look at coal. Coal, which is an important fuel source, 101 more years, but at current rate of acceleration, only 21. Coal is potentially going to run out in 2057. So let's have a think about the question here. What's more likely to happen? Table A or Table B? Remember, Table A is if production rate remains at the current level, and B if it accelerates at the current level. So A is at the current rate, B is at the current rate of acceleration. So we're on an upward trajectory in each case, an upward trend. B is more likely. It's likely to follow that acceleration trend. The alternative is that everything is going to suddenly stop accelerating and stay where it is. And we don't have evidence that that is going to happen. That takes us to the end of this video. Thank you for listening and goodbye.